Good morning, all of you. My voice is audible to you. My voice is audible. Screen is visible. Please give me reply. Okay. Okay. So in our last lecture, we have completed our transaction chapter. So today we will start our next chapter, that is concurrency control. Okay. So this concurrency control point means in the transaction chapter, one point of concurrency control was there. Okay. So exactly concurrency control means we know that the properties of transaction, that is acid properties of transaction. So among that, one property called as the isolation. Okay, so isolation, it is one of the property of the transaction. So that isolation means what? When what if multiple transactions are there, and when one transaction is executing, then at the same time no other transaction is allowed to execute. Okay, means what? At a single time, single transaction must execute. If another transaction is there, then that transaction must execute after execution of the first transaction. Okay, or the second transaction must execute first, and then the first transaction will start its execution. Okay, means what? At the same time, only single transaction is allowed to execute. So that is nothing but the isolation. But if a number of transactions are there, okay, then we have to control the execution of all the transactions. Okay, means in some cases it is required that if the multiple transactions are executing simultaneously, then the system may execute some part of the transaction for some time, and then it will switch to another transaction, and there it will execute some part. Okay, and again it will switch to the first transaction, and it will execute the some part of the first transaction, and again it will execute switch to the second transaction, and it will execute some part of the second transaction. Okay, so this scheme, or this execution is called as the concurrent execution of the transaction. And to control or to handle such cases, we require the concurrency control mechanism or the concurrency control scheme. Okay, so the concurrency is nothing but the concurrent execution of the transaction. Okay, so the uh, concurrency means what? The concurrent execution of the transaction means what? Simultaneously we can execute multiple transactions. Obviously, if we are executing simultaneously multiple transactions, then some problems or some error may occur. So to handle such kinds of problems, we require the concurrency control mechanism. Okay, so in the concurrency control mechanism, so we will see the first point, that is lock based protocol. So these this lock based protocol, then timestamp protocol, validation, deadlock handling. Okay, so these are the schemes to handle the concurrency control mechanism. Okay, have you understood what is meant by concurrency control mechanism or the concurrency control? Okay, so to run the transaction in the isolation, or to achieve the property of the isolation of the transaction, we require the concurrency control mechanism. Okay, so the first point of the chapter is lock based protocols. Okay, means what? Some to handle the concurrency control mechanism, some protocols are there, and one of the protocol is nothing but the lock based protocols, where we are using the lock system. Okay, locking system means what? uh, to access the data item. So I am I'm taking the lock on that data item. Okay, so the lock based protocols are nothing but they give or they allowed to lock a particular data. Okay. So we know that when the several transactions they execute concurrently in the database, so the isolation property may no longer be preserved. Okay, we have seen this point that if the multiple execution of the transactions are there, then it will be possible that the isolation property it will not be preserved. Okay, so to ensure that the system must control the interaction among the concurrent transaction. Okay, means our system, our operating system must have to control the execution or the interaction among the multiple transaction, and this control is achieved through the concurrency control mechanism scheme. Okay, so this interaction between the multiple transactions. Okay, so this control is achieved with the help of concurrency control management. Okay, so we will see a number of concurrency control schemes. So among that, the first scheme is the lock system. Okay, or the lock mechanism. So this lock mechanism is used to control the concurrent access to the data item. Okay. This lock mechanism is used to control the concurrent access to the data item. Okay, so how the lock system uh, is used to control the uh, data items? Okay, means what? Whenever any transaction want to execute any data item, or whenever any transaction want to execute any kind of operation, so in that operation the transaction uses some data items. Okay, we have seen that what is the data item. Okay, so that data item is nothing but the any variable. Okay, so every transactions are using different variables. So now uh, in some cases it is possible that a same variable it is used by number of transaction, or the same data item is used by the number of transactions. Okay, so at that time the problem may occur. Okay, means what? If the data item is used by one transaction, and if the same data item is used by the another transaction. Okay, and if both are executing the operation using that data item, then it may possible that uh, the final result of the data item or the final result of the transaction may be in the inconsistent state. Okay, because both the transactions are not knowing that they are using the same data item. So it may possible that if both the transactions are executed simultaneously, then inconsistent result may arise. Okay, so we can avoid such kinds of inconsistent state with the help of lock system. So there are two types of locks, or we can say that uh, the transaction can lock the data item in the two modes. Okay, so two modes are, first one is the exclusive mode and the next one is the shared mode. Okay, so the exclusive mode means what? So it is denoted by the X, and the shared mode it is denoted by the S. Okay, so the exclusive means what? So if the transaction has acquired the lock on the data item, okay, means if the transaction has acquired the exclusive mode lock, then that transaction can read or write the data item. Okay, exclusive means what? The data item can be both read as well as written. Means that transaction can read the data item also, and that transaction can write the data item also. Okay? So this exclusive mode lock is requested using the lock X instruction. Okay, this instruction means before using that lock, first we have to, or first that transaction have to lock that instruction. Okay, so if the transaction want to lock the instruction using the exclusive mode, then uh, this particular instruction must be executed, that is lock dash x. Okay, now the second mode of the lock is the shared mode lock. So in the shared mode lock, the transaction can only read the data item. Okay, if the transaction has acquired the lock on the data item, okay, means the shared mode lock, then that transaction can only be read the data item. Okay, so this shared mode lock is requested with the help of lock s instruction. Okay, so for the exclusive mode lock, lock x instruction was there, and for the shared mode lock, lock s instruction is there. Okay, so the lock requests are made to the concurrency control manager, and the transaction can proceed only after the request is granted. Okay, means what? If any transaction want any kind of lock on the data item, then the steps are: the first, the transaction has to request the particular lock to the concurrency control manager. Okay, so this concurrency control manager is handled all the process of lock system. Okay, so first the transaction has to give request to the concurrency control manager regarding the particular lock mode. Okay, so if that lock mode or if that data item is available, means no other transaction has acquired the lock on the data item, then the concurrency control manager, it allocates that lock to it allocates the data item to that particular transaction. Means what? That concurrency control manager, he allows the particular lock mode on the particular data item. Okay, and means what? That transaction is granted. Sorry, the concurrency control manager gives the grant to the transaction. Okay, so in this way, if the transaction want lock on the data item, then first the transaction has to give request to the concurrency control manager regarding the lock and the data item. Okay, if the data item is free, or if no other transaction has acquired the lock on the same data item, okay, then and then only the concurrency control manager grant the lock to that transaction. Okay, so after the lock granting, transaction can proceed its execution. Okay, so if the concurrency control manager has not granted the lock to the transaction, then that transaction is not proceed for the further operation. That transaction must have to wait for some time. Okay, so this is the basic lock system. So two kinds of lock modes are there. First one is the exclusive mode, and the next one is the shared mode. Exclusive mode locks are nothing but the transaction can both read and write the data item. The shared mode lock are nothing but the transaction can only be read the data item. Okay, now there is a lock compatibility matrix. Okay, lock compatibility matrix means what? If two transactions are there, or if more transactions are there, and if one transaction has acquired the lock on the data item, and if another transaction also request for the lock on the data item, then the concurrency control manager first check the compatibility between the locks. Okay, if the compatibility of the lock is satisfied or it is allowed, then the concurrency control manager gives the lock to another transaction. Okay, so the transaction may be granted the lock on an atom if the requested lock is compatible with the lock already held on the atom by the other transaction. Okay, so this compatibility matrix or the lock compatibility, it require if So if both the transactions they are requesting the lock on the same data item, okay, so in that case only the compatibility matrix is required. Okay, so the concurrency control manager checks the compatibility of the locks. Means if the data item is already locked by one transaction and if the another transaction is requesting lock on the same transaction, then at this time the concurrency control manager check the compatibility of the lock. Okay, so if the compatibility is allowed, then the concurrency control manager gives lock to that transaction. Okay, so while uh, requesting the lock or while granting the lock, so any number of transactions can hold the shared locks on the data item. Okay, means what? Consider if there are 10 transactions, then all the 10 transactions can acquire the shared mode lock on the same data item. Okay, shared mode lock means what? All the transactions can read that data item. Okay, so reading is allowed for multiple transactions, but if any transaction holds an exclusive lock on the data item, then no other transaction may hold any lock on that item. Okay, what they have written here. So if the number of transactions are there, then all the transactions can hold the shared mode lock on the data item. Means all the transactions can simultaneously read the same value of the data item. Means the shared mode lock is allowed for number of transactions. But if any transaction has uh, if any transaction holds the exclusive mode lock on the data item, then at the same time no other transaction is allowed to lock uh, the data item. Okay, means no other transaction is allowed to uh, lock any kind of lock on the data item. Okay, so this compatibility is nothing but, okay, shared shared exclusive. Okay, so here only the shared uh, locks are the compatible locks. Means consider T1 and T2 transactions are there. Okay, so if transaction T1 has acquired the shared mode lock on the data item, okay, and if transaction T2 is here, so if the transaction T2 is requesting the shared mode lock on the same data item, then it is allowed, or we can say that it is compatible. Okay, but the transaction T1 has acquired the shared mode lock on the data item and transaction T2 is requesting the exclusive mode lock, then it is not allowed, or we can say that these two locks are not compatible. Okay, so similarly for the shared exclusive and for the exclusive. Okay, so if the exclusive mode lock uh, is there on the data item, then only that transaction is allowed to access that data item, and at the same time no other transaction is allowed to acquire any kind of lock on that data item. Okay, so in the lock compatibility mode or in the lock compatibility matrix, only the shared mode locks are compatible with each other and the other locks are not compatible with each other. Okay, here the transaction requests a shared lock on the data item q by executing the lock s in bracket q instruction. Okay, so this q is nothing but the data item. So if the transaction uh, requesting for the shared mode lock on the data item q, then the transaction must have to execute the lock s in bracket q this instruction. Okay, similarly similarly for the exclusive lock, so the transaction must have to execute the lock x in bracket q instruction. Okay, so similarly, if the transaction has completed its execution with the uh, with the data item, then that transaction must have to unlock that data item. Okay, so that unlocking of the data item, it is executed by the instruction unlock in bracket q. Okay, so every transaction have to unlock the data item after completion of its execution. Okay, so if the transaction is not unlocking the data item even after completion of the execution also, then other transactions are waiting for that particular data item. Okay, understanding the unlocking concept. So if I'm having one data item, or if I have acquired any kind of lock on the one data item, okay, then after completion of my execution of that data item, so I have to unlock that data item so that other transaction or the other person can use that data item. Okay, understood. The compatibility matrix in the lock based protocol. So in the compatibility, or if uh, n number of transactions are there, then only the shared mode locks are allowed on n number of transactions. Means only the shared this lock system or this lock mode is only the compatible mode. Okay, and the other modes are not compatible with each other. Okay, so uh, in case of transaction, to access the data item, the transaction ti, consider ti, so that transaction must first log that data item. Okay, so we have seen this point. Means before accessing the data item, any transaction must have to lock that data item in any mode. Okay, if the data item is already locked by another transaction in an incompatible mode. Okay, so here incompatible mode means what? Either it may be shared exclusive, okay, or it may be exclusive. Okay, so if the data item is already locked by another transaction, means what? If the data item is already with any another transaction in an incompatible mode, then the concurrency control manager will not grant the lock until all the incompatible locks held by other transaction have been released. Okay, so if that data item is currently with the another transaction, okay, but in the incompatible mode, then the concurrency control manager will not grant the lock until all the incompatible locks by the other transaction have been released. Okay, so in this case the transaction ti is made to wait until all the incompatible locks held by other transaction have been released. Okay, means here the transaction ti has requested the lock on the data item, but currently that data item is with another transaction, consider tj. Okay, so that data item is with another transaction in a incompatible mode. Okay, so in this case the transaction ti has to wait until all the incompatible locks held by that tj transaction have been released. Okay, means what? Uh, in the locking system, the wait concept is there. Means if the data item is not available at that time, okay, then that particular transaction have to wait for some time until the other transaction has released that lock. Okay, understood the locking concept or the lock based protocol concept. Okay, now the schedules. Okay, so we have seen the schedule. So the schedules are nothing but the sequence of the instructions of the transaction. Okay, so we will see one example of the schedule with the log grant. So you can see here transaction T1 and transaction T2 are there, and here the concurrency control manager what we can say instructions are there. Okay, so every transaction first requesting the lock, okay, on any data item, and after that the concurrency manager grant that particular lock on the data item, and after that only the instructions or the operations of that particular transaction starts. Okay, so here assume that the grant happens just before the next instruction following the lock request. Okay, means what? After the lock request, whatever the next instruction is there, so before that next instruction, the lock has been granted by the concurrency control manager. Okay, now see here. So this transaction T1 and transaction T2 are there. Okay, so if this transaction T1, or we can say if both the transactions are executed serially, then they will give us the correct result. Okay, serially means you know that either first T1 will execute, or then T2 will execute. Okay, so if both the transactions are executed concurrently, okay, concurrently means like this only, means up to the unlock B, this transaction T1 will execute, okay, after this part of the T2 will execute, and then this part of the T1 will execute. Okay, so if the concurrent execution of the transaction is there, then the transaction then both the transaction, they will give us the inconsistent state. Okay, means what? So here the first request is the lock X on the B, means the transaction T1 has acquired the exclusive mode lock on the B. Okay, so the first instruction is read B. B is equal to B minus 50. Consider the value of B is 100. Okay, so B minus 50 uh, means 100 minus 50, again 50. Then he has written the value of B. Okay, that is 50. Now here, so it will execute here. Read A. Okay, consider the value of A is 200. Okay, then unlock A, means this transaction T2 has used this data item A, then he has unlocked that data item. Then lock S on the B, means transaction T2 has acquired the shared mode lock on the data item B. Then read B. Okay, so current value of B is 50. Okay, then after 50, display A plus B. Okay, A plus B. So here value of A is 200 plus value of B is 50. So here it will gives us the inconsistent result, that is 250. Okay, if both the transactions are executed serially, means one after another, then they will give us correct answer as a 300. Okay, but if both the transactions are executing concurrently, then they will give us, means transaction T2 is in the inconsistent state. Okay, so why this happens? So because the transaction T1 has unlock the data item B too early. Okay, so this if the transaction T1 has unlocked the data item B just after the write operation on the B, so whenever in the transaction T2, whenever we are reading the value of B, so we are reading the value that is 50. Okay, means whatever the return by that transaction T1. Okay, so this schedule is not the serializable schedule. Okay, so this is the one example of the schedule with the lock grant. Okay, now the one concept in the lock based protocol is the deadlock. So the deadlock is very we can say common concept, okay, in every transaction. Okay, so consider the two transactions, transaction T3 and transaction T4. Okay, So in this case, first we will see the instructions of the T3 and T4. So instruction of the T3 are lock X on the B, means shared mode lock on the B. So transaction T3 has read the value of B and transaction then B minus 50 and then write the value of B. Okay, so after this the system will switch to the transaction T4. Transaction T4 here acquire the shared mode block on the data item A, then uh, read the value of A. Okay, then lock S, means shared mode lock on the B. Okay, and after that again it will switch to the transaction T3 and it will execute or it will request the shared exclusive mode lock on the data item A. Okay, so please see all the instructions very carefully. So here no any unlock instruction is there. Okay, means what? First, the transaction T3 has acquired the exclusive lock on the B. Okay, so we know that if one transaction has acquired the exclusive lock on any data item, then no other transaction is allowed to lock that data item. Okay, so transaction T3 has acquired the exclusive lock on the B, but he has not unlocked that data item. Okay, then in the T4, okay, in the T4, transaction T4 has acquired the shared mode lock on the data item A. Okay, and here also that transaction has not transaction T4 has not unlocked that data item A. Okay, and in the T4 only, okay, in the T4 only we are requesting the shared mode lock on the data item B. Okay, but actually the data item B is with the transaction T3 and yet transaction T3 has not unlocked that data item B. Okay, means what? This data item is not data item B is not available to the transaction T4. Okay, means what? Not a single transaction is executing here. Okay, means what? Transaction T4 is waiting for the transaction T3 to release the data item B, and here the transaction T3 is waiting for the transaction T4 to release the data lock on the data item A. Okay, means here both the transactions are not both the transactions have not completed their execution and they are just waiting for each other. Okay, so this kind of situation is nothing but the deadlock. Understood what is meant by deadlock? Okay, so here we can read here explanation. Okay, so here neither T3 nor T4 can make progress. Means what? These two transactions, they are as it is, their execution is as it is, their execution is not completed yet, or they cannot make any kind of progress. Okay, because executing the lock S on the B, okay, this lock S on the B, it causes T4 to wait for the T3 to release its lock on the B. Okay, if T4 want to execute the shared mode lock on the data item B, but currently the data item B is with the transaction T3. Okay, so T4 has to wait up to the transaction T3 to release the lock on the data item B. Okay, similarly, executing the lock X on the A, it causes transaction T3 to wait for the T4 to release the lock on the data item A. Okay, means what? Both the transactions are waiting for each other. Okay, for releasing the lock. So this situation is nothing but the deadlock. Understood? Okay, so we are having the deadlock in our next point also. Okay, but here the small concept of the deadlock is given. Okay, so this situation means both the transactions are waiting for each other to release the lock. So that is nothing but the deadlock in the system. Okay, so to handle the deadlock, one of the T3 or the T4 transaction must be rolled back and its locks are released. Okay, so if we want to handle the deadlock between between the transaction, then one of the transaction have to roll back so that their locks are released. And if the locks are released of one of the transaction, then another transaction can use that locks or use the locks on the data item. Okay, are you understanding the concept of deadlock? Okay, so uh, we have seen the definition of the deadlock. Now, each transaction in the system follow the set of rules. Okay, so if the transaction want to execute their operation, then they have to follow some kinds of rules, and these rules are called as the locking protocol. Okay, so this locking protocol itself is nothing but the set of rules that this every transaction must follow. Okay, so these locking protocols indicating that when the transaction may lock and unlock each of the data item. Okay, so these locking protocols, they indicate that when a transaction is acquiring the lock on the data item and when the transaction is releasing that data item, that is unlock the data item. Okay, the locking protocols restrict the number of possible schedules. Okay, the set of all such schedules is a proper subset of all possible serializable schedules. Okay, so uh, uh, means the series of schedules. Okay, so this series of schedules we can achieve with the help of locking protocol, and all such series of schedules is nothing but the proper subset of all possible serializable schedules. Okay, so this, if we are using the locking protocol, means we can achieve the schedules, and all the schedules are, or the combination of all the schedules are nothing but the serializable schedule. Okay, so the serializable schedule means we know that one uh, means after the execution of the transaction also, the uh, the transaction must be in the consistent state, then we can call that kind of schedule as a serializable schedule. Okay, now the second point of the lock based protocol is the granting of locks. Okay, so the granting of lock, first when the transaction want to use the data item, then we know that that transaction must have to request the lock on the data item to the concurrency control manager. Okay, and concurrency control manager checks that whether the data item is available or not, or whether any other transaction has acquired the lock on that data item or not. Okay, the concurrency control manager checks this possibility, and if the data item is free, then the concurrency control manager grant the lock on that data item. Okay, so here consider that the transaction T2. Okay, so transaction T2 has the shared mode lock on the data item, and the another transaction T1 requests the exclusive mode lock on the data item. Okay, means here uh, currently the transaction T2 is holding the shared mode lock on the data item, and transaction T1 is requesting the exclusive mode lock on the data item. Okay, so the concurrency control manager has not uh, has not grant uh, has not grant to the transaction T1 because the locks are in the incompatible mode. Okay, so we know that the locks are in the incompatible mode means what? The transaction T1 has to wait for transaction T2 to release the shared mode lock. Okay. So meanwhile or in between another transaction, consider the transaction T3. Okay. So transaction T3 may request the shared mode lock on the same data item. Okay. So this lock request is the compatible request. Okay. So this lock request is the compatible with the lock granted to the T2. Okay. So this transaction T3 may be granted the shared mode lock. Okay. We have seen that the shared both are compatible. So if the another transaction T3 is requesting the shared mode lock on the same data item, okay, then the both request or this request is the compatible request. So the concurrency control manager granted the shared mode lock on the data item for the transaction T3. So now here, suppose the transaction T2 may release the lock. Okay, transaction T2 may release the lock, but still the transaction T1 has to wait for the T3 to finish because currently that data item is with the transaction T3 because T3 has granted the shared mode lock on the data item. Okay, so again transaction T1 has to wait for the transaction T3 to release the lock or to finish its execution. Okay, but again consider that a new transaction, that is transaction T4, request a shared mode lock on the same data item. Again this request is the compatible. Okay, so the concurrency control manager granted the lock to the transaction T4, okay, before T3 releases it. Okay, means what? It is possible that there is a sequence of transactions that each request a shared mode lock on the data item. Okay, means consider that there are number of transactions and all the transactions are requesting the shared mode lock on the same data item. Okay, and each transaction releases the lock a short while after it is granted, but T1 never gets the exclusive mode lock on the data item. Okay, because the number of transactions are there and all the transactions are requesting the shared mode lock on the same data item, and T1 has also requested the lock on the data item but in the exclusive mode. Okay, so this T1 has to wait for n number of times. Okay, so this T1 has to wait for n number of times until all the transactions that acquired the shared mode lock on the same data item. Okay, so that transaction T1, he never gets the exclusive mode lock on the data item. Means what? The transaction T1 may never make the progress. So it is called as the starved. Means we can say that the transaction T1 is the starved. Means the transaction T1 has to wait for n number of times and that transaction T1 never gets the exclusive mode lock on the data item. Okay, so this situation is called as the starvation. Starvation means we can say that the transaction T1 is starved. Okay, so this is the concept of the granting of locks. Okay, we know that the concurrency control manager, he grants the lock to the transactions. Okay, so if while granting the locks to the transaction, the concurrency control manager first have to check whether that data item is uh, uh, currently acquired by any other transaction or not. Okay, so if the data item is currently acquired by any other transaction, then the concurrency control manager have to check the compatibility of the lock. Okay, so if the lock request coming from the new transaction, if the lock request is the compatible lock request, then the concurrency control manager grant the lock to that new transaction. But if the lock request is the incompatible lock request, then that transaction have to wait for number of times and number of times. Okay, so if that transaction has to wait for the n number of times, means what we can say that here the starvation may occur. Understood the concept of starvation? Okay, so in this example, means in our example, we can say that the starvation is occurred and the transaction T1 is starved. Okay, understood? Are you understanding the concept of the deadlock? Okay, we have seen the concept of the deadlock. So here also the transactions they never make the progress. Okay, and in the granting of locks also, if the lock request is the incompatible lock request, okay, so and the sequence of transactions are requesting the shared mode lock on the data item, then we can then the starvation may occur. Okay, so in case of granting of locks, so this starvation, so we can avoid the situation of the starvation of the transaction by granting the locks. Okay, so how to avoid the starvation by granting the locks? So first, when the transaction Ti requests a lock on the data item Q in a particular mode M, means in any mode. Okay, either it may be exclusive or it may be shared. Then the concurrency control manager grants the lock provided that first, there is no other transaction holding a lock on the queue. Okay. Transaction, if the transaction Ti requests a lock on the data item Q in particular mode, then the concurrency control manager grants the lock and the concurrency control manager checks that there is no other transaction holding a lock on the data item Q in a mode that conflicts with the M. Okay, so the concurrency control manager checks that there is no any other transaction that holding the lock on the queue, okay, lock on the queue in a mode that conflicts with the current mode of the transaction. Okay, and the second point is that there is no other transaction that is waiting for the lock on the queue and made uh, and that made its lock request before Ti. Okay, so the second possibility to avoid the starvation is that there is no other transaction who is waiting for the lock on the data item Q. Okay, so these two are the possible ways to avoid the starvation. Okay, so the first way is that the concurrency control manager must have to check that no other transaction that holding the lock on the data item Q in a conflicting mode. Okay, and no other transaction has to wait. No other transaction that is waiting for the uh, lock on the data item Q. Okay, so if concurrency control manager checks these two situations, then we can avoid the starvation of the transaction or the starvation between the transaction. Okay, understood the granting of locks and uh, uh, if the starvation occurs in case of granting of lock, then how to avoid that starvation of the transaction. Okay. Now in the locking protocol, the main uh, or the important locking protocol is the two-phase locking protocol. So this two-phase locking protocol, it ensures the conflict serializable schedule. Okay, so this conflict serializable schedule means we have seen that any deadlock situation or any starvation occurred between the transaction. Okay, so this two-phase locking protocol, it is used to ensure such kinds of conflict serializable schedules. So as the name suggests, two-phase locking protocol means this protocol is having the two different phases. Okay, phase 1 is nothing but the growing phase, and phase 2 is nothing but the shrinking phase. Okay, so as the name suggests, growing phase. So you can see here in the diagram. Okay, so the growing phase means what? In the upward direction, or means the transaction in the growing phase, the transaction may obtain the locks. Okay, means transaction may take the lock but may not release any lock. Okay, because the phase is a growing phase. So here the transaction may obtain the locks but not release any lock. And the second phase is the shrinking phase. Okay, so in the shrinking phase means this phase. Okay, so here the transaction may release the lock but not obtain any lock. Just a minute. Okay, so in the growing phase, the transaction only obtain the lock but not release any lock. And in the shrinking phase, the transaction may release any lock but not obtain any lock. Okay, so this two-phase locking protocol, it assures the serializability of the transaction. Okay, so it can be proved that the transactions can be serialized in the order of their lock points. So this lock point is nothing but the transaction where means the point where the transaction acquired its final lock. Means what? You can see in the diagram this point. Okay, so in the growing phase, we know that the transaction can acquire or transaction can obtain the lock. Okay, so up to this point only the transaction can obtain the lock. Means the lock point is nothing but the point at which the transaction can acquire its final lock. Okay, means after that point the transaction cannot acquire any lock. So transaction can release the lock. Okay, so that point is called as the lock point. Okay, so this two-phase locking protocol, this protocol assures the serializability of the transaction. Okay, and the transactions can be serialized in order to in order of their lock points. Okay, so we have seen the lock point means what? So the point where the transaction acquired its final lock is called as the lock point. So this two-phase locking protocol does not ensure the freedom from the deadlock. Means what? If we are using the two-phase locking protocol, then also the deadlock may occur in the system, or deadlock may occur between the transactions. So this cascading rollback, okay, we have seen this cascading rollback in the transaction chapter. So this cascading rollback may occur under two-phase locking. Cascading rollback means what? If the number of transactions are depend on the single transaction, then if that single transaction is aborted, then we have to roll back all the series of transaction. That is nothing but the cascading rollback. So this cascading rollback may occur in the two-phase locking protocol. Okay, so there are two extensions of the two-phase locking protocol to ensure the recoverability of freedom from the cascading rollback. So the first extension of the two-phase locking protocol is the strict two-phase locking protocol, and another one is the rigorous two-phase locking protocol. Okay, so the strict two-phase locking protocol means what? This protocol requires not only that locking be two-phase. Okay, means here the locking is allowed to be two-phase, but also that all the exclusive mode locks taken by the transaction, okay, all the exclusive mode lock taken by the transaction be held until that transaction commits. Okay, means until that transaction commits. So all the exclusive mode locks are as it is with the transaction. Okay, until the transaction commits its execution. That is nothing but the strict two-phase commit protocol. So in the strict two-phase commit protocol, we can say the two important points. The first point is that the locking should be two-phase locking, means growing and shrinking phases are there, and additionally all the exclusive mode locks are with the transaction only until that transaction commits. Okay. So this requirement ensures that any data written by the uncommitted transaction are locked in the exclusive mode until the transaction commits. Okay, so even though the transaction is the uncommitted transaction, then also then also the data items are locked in the exclusive mode until the transaction commits. Okay, and preventing the any other transaction from reading the data. Okay, so this is the requirement of the strict two-phase locking protocol. Okay, the first requirement is the phases should be two-phase, or the locking should be two-phase, and until the transaction commits, all the exclusive mode locks are with the transaction only. Okay. Now the next extension of the two-phase locking protocol is the rigorous two-phase locking protocol. Okay, so in the rigorous two-phase locking protocol, the transaction must hold all the locks till it commits or the abort. Okay, so in the rigorous two-phase locking protocol, a transaction must hold all the locks. All the locks means whether it may be exclusive mode lock or it may be the shared mode locks until the transaction can commit or abort. Okay, just the difference between strict two-phase and the rigorous two-phase is that in the strict two-phase, until the transaction commits, it holds all the exclusive mode lock. Okay, it holds only all the exclusive mode lock. And in the rigorous two-phase locking protocol, it holds all kinds of lock until the transaction commits. Okay, so if we are implementing such extensions of the two-phase locking protocol, then we can say that the deadlock may not occur in the system, so that deadlock may not occur in the system, and also we can take freedom from the cascading rollback. Okay, so this was about the two-phase locking protocol, growing, shrinking phase, and the lock point. Then the extension for the two-phase locking protocol to ensure the recoverability of the cascading rollback. Okay, so we can use the strict two-phase locking and the rigorous two-phase locking. So in the strict two-phase locking, we know that the exclusive mode locks are taken by the transaction until the transaction commits, and in the rigorous two-phase locking protocol, all kinds of locks are held by the transaction until it commits. Then one sub point in the two-phase locking is the lock conversion. Okay. Lock conversion means what? We can convert, means if the shared mode lock is there, then we can convert to the exclusive mode lock. Okay, so if the exclusive mode lock is there, then we can convert it to the shared mode lock. It is nothing but the lock conversion. So this two-phase locking with the two-phase locking protocol, we can use the lock conversion. Okay, lock conversion is nothing but the we can upgrading a shared lock to the exclusive lock. Okay, means we can convert the shared lock to the exclusive lock, but it is called as the upgrading. Okay, and we can downgrading an exclusive lock to the shared lock, means we can convert the exclusive lock to the shared lock. So it is called as the downgrading or the downgrade. Okay. So we denote or we call this conversion from the shared to the exclusive mode by the upgrade. So if there is a conversion from the shared mode to the exclusive mode, okay, so it is called as the upgrade. And if the conversion is from the exclusive mode to the shared mode, then it is called as the downgrade. Are you understanding? When we can call the conversion as the upgrade, so if it is from the shared to the exclusive, and if the conversion is from the exclusive to the shared, then we can call it as the downgrade. So in the growing phase, in the two-phase locking, the first phase is the growing phase. So we can acquire the lock S on the data item, means shared mode lock on the data item, and also we can acquire the exclusive mode lock on the data item, and then we can convert the exclusive mode then we can convert the shared mode lock to the exclusive mode lock. So it is called as the upgrade, means upgrading is possible in the growing phase. Okay, and in the shrinking phase, we know that in the shrinking phase we can release the lock. Okay, so here we can release the shared mode lock and we can release the exclusive mode lock, and we can convert the exclusive mode lock to the shared mode lock. So it is called as the downgrade, and the downgrade is possible in the shrinking phase. Okay, so this kind of lock conversion it ensures the serializability, means if we perform the lock conversion in the two-phase locking protocol, then we can achieve the serialized schedule. Okay, so this one is for the two-phase locking protocol. So with the help with the two-phase locking protocol, we can use the lock conversion. So lock conversions are nothing but we are using upgrading of the lock or downgrading of the lock. Okay, so the upgrading of the lock means shared to the exclusive mode, means we can just convert, okay, shared mode lock to the exclusive mode lock, and the downgrading is nothing but we can just convert the exclusive mode lock to the shared mode lock. Okay, and remember that in the growing phase, whenever we are acquiring the lock, so at that time only we can convert the shared mode lock to the exclusive mode lock. Okay, And in the shrinking phase, whenever we are releasing the lock, at that time we can convert the exclusive mode lock to the shared mode lock. So that is nothing but the downgrade. Okay. Now the next point is the implementation of the locking. So the lock, if we want to implement the locking concept, then we require the lock manager. Okay, so this lock manager can be implemented as the separate process. Every transaction can send the lock and unlock request as the messages to the lock manager, and every lock manager he gives a reply to the transaction by sending the lock grant message, okay, to every transaction. Then the requesting transaction waits until its request is answered. Okay, so whatever the transaction, okay, so if the transaction is requesting the lock to the uh, lock manager, okay, then that requesting transaction must have to wait until its request is answered. Okay, so the lock manager, it maintains the in-memory data structure, that is the lock table. So to implement the locking, lock manager uses the lock table. So in the lock table, all the locks or all the transactions are stored. Okay, and the record of all the transactions are stored in the linked list manner. It means in the lock table, or the lock table maintains the linked list of the records. Okay, so one for each request in order in which the request arrived. Okay, we know, you know that the structure of the linked list. Okay, means we can say one record and after the new record. Okay, it means both the records are joined with the link, we can say that. Okay, so list of records are joined with the link. So here the lock table also maintain the records in the linked list manner. Okay, so every lock manager uses the lock table data structure. Okay, so this lock table data structure is used to record the granted locks, okay, and the pending request. Means if the transaction has requested if the transaction has requested the lock to the lock manager, and if that request is granted, if that lock is granted, then the lock table stores the record of such granted locks. Okay, and suppose that one transaction has requested the lock on the data item, but this request is still pending. Okay, means if the lock is not granted to that transaction, means what, the request is pending. So this lock table also stores the record of such pending request. Okay, so for implementing the lock in the system, we are using we are using the lock manager. Okay, so this lock manager, it handles all the lock and unlock request of the transaction. Okay, so if the transaction want to lock any data item, then first the transaction has to send the lock request message to the lock manager. Then lock manager checks whether the data item is available or whether the data item is not locked by any other transaction. Okay, so if the data item is available, then the lock manager uh, immediately gives reply to that transaction. Okay, and if the data item is not available, then the transaction has to wait for some time. Okay, so this granting of locks and the pending locks. Okay, so both the information of both the locks is stored in the lock table, and this lock table is maintained by the lock manager. Okay, so in the lock table, the records are stored in the form of linked list of records. Okay, so uh, this is the representation of the log table. Okay, so in the log table, we know that the records are stored in the linked list manner. Okay, consider here I7 and I23. Okay, so this I7, I23, I9, 12, I4, I44. Okay, so these are the data items, and T3, T1, T8, T2. Okay, uh, T20, T23. Okay, so they are the transactions. So this is the log table, and in the log table, uh, the records are stored in the linked list manner. Means here I7 data item and the new data item arrives, that is I23. So both the data items are connected with the list. Connected with the link. So in this diagram, dark rectangles are there and some light color rectangles are there. So these dark rectangle are nothing but the granted logs. Okay, means what? Transaction T3 uh, means currently the data item I7 is currently with the transaction T3, and the transaction T3 has granted the lock on the uh, data item I7. Okay, and this light colored rectangles or boxes are nothing but the waiting request. Okay, means what? The transaction T2 is waiting for the transaction T8 to release the lock on the data item I23. Okay, so this dark colored box is nothing but the granting locks, and this light colored box is nothing but the waiting box or the waiting request. Okay. So this log table, it also records the type of the log granted or the requested. So if the new request arrives, then this new request is added to the end of the queue of the request for that data item. Okay, it means consider for the I23, for this data item, first transaction T1 has requested the lock on the I23. Okay, and suppose the lock manager has granted the lock on the I23, then T1 can use the transaction I23. So transaction T1 can use the data item I23. But after some time, suppose the transaction T8 has requested the lock on the same data item, that is I23. Okay, and if the transaction T1 has completed its execution, okay, then transaction T8 has allocated the lock on the I23. Okay, means what? This T8, this new request is arrives, then this new request is added to the linking or chaining of the transaction. Okay, so for the unlock message, means we have seen for the lock message or the new request. So for the unlock message from the transaction, so it deletes the record for that data item in the linked list. Okay, so if the unlock message is there, consider from the T1, then the lock manager deletes that transaction uh, transaction or deletes the record for that data item in the linked list corresponding to that transaction, and later requests are checked to see if they can now be granted. Suppose consider the transaction T8. Okay, transaction T8 had sent the unlock message for the I23. Okay, so the lock manager deletes this entry of the transaction T8 from the lock table. Okay, and if the transaction aborts, then all waiting or the granted request of the transaction are deleted. Okay, consider because of any reason transaction T23 or the transaction T8. Okay, if the transactions are abort, then all the waiting or the granted request of the transactions are deleted. Okay, so every lock manager may keep the list of locks held by each transaction to implement this efficiently. Okay, so this uh, every lock manager uh, uses the lock table. Okay, or we can say every lock manager it keeps the list of locks taken or held by the transaction. Okay. So this lock table contains the linked list of the lock request. Okay. So if uh, for the same data item, if the new request is arrives, okay, then this new request is added to the end of the uh, end of that list, or end of that list of data item. Okay, and if the unlock request is there or unlock message is there, then the lock manager deletes that entry from the linked list or deletes that transaction. Okay, and in case of if the transaction abort, then the lock manager deletes all the waiting and the granted request from the lock table. Okay, understood? The implementation of locking or the implementation of lock. So, two, 3 points about implementation of lock are lock manager. Okay, lock manager handles the lock and unlock request from the transaction. Then second point is the lock table. Okay, lock table it stores the record of the that is it stores the record of granting of locks and pending of lock request, and the lock table stores the record in the linked list manner. Okay, so every lock table contains the series of locks, or we can say the linked list of the locks. Okay, and if for the same data item, if the new request arrives, okay, a new request from the new transaction arrives, then it is also added to the end of the queue of the list. Okay, and in the lock table, means in this diagram, uh, both that is granted locks and waiting locks are indicated. Okay, understood? Implementation of locking. Okay, so I think we will stop here today. Okay, we'll stop here today and we'll see the next point in our next chapter, in our next lecture. So just call your numbers, give me presentee. Roll number 1,
Present.
2,
Present, ma'am.
next 3, roll number 3, 4,
For present, ma'am.
5,
Present, ma'am.
6,
Present.
7, 8,
Present.
9,
9 present, ma'am.
10,
Present.
11, 12, 13,
13 present, ma'am.
14,
Present, ma'am.
15, Hello? Am I audible? Hello?
Yes, ma'am.
Ah, okay. So some network error has occurred. Uh, Roll number 15. 15. Absent. 16.
Present, ma'am.
17. 18.
Present, ma'am. Present, ma'am.
19.
Present, ma'am.
20.
Present, ma'am.
21. 22.
Present, ma'am.
23.
Present, ma'am.
24.
Present.
25.
Present,
26.
ma'am.
Present, ma'am.
27.
Present, ma'am.
24.
27.
28.
28. 28. Present, ma'am.
29.
Yes, ma'am.
30.
Yes, ma'am.
31.
Yes, ma'am.
32.
Present, ma'am.
33.
Present, ma'am.
34.
Present, ma'am.
35.
35 present, ma'am.
36.
36 present, ma'am.
37.
Present, ma'am.
38.
Present, ma'am.
39. 40.
40 present, ma'am.
41. 42. 43.
Yes, ma'am.
44.
Yes, ma'am. 44.
45. 46.
Present, ma'am.
47.
Yes, ma'am.
48. 49.
Present, ma'am.
49.
Yes, ma'am.
50.
Present, ma'am.
51.
Present, ma'am.
52. 53. 54.
Present.
55.
Present.
56.
Present.
57. 58.
Present, ma'am.
59.
Present, ma'am.
60. 61.
Present.
62.
60 present, ma'am.
62. 63. 64.
Present, ma'am.
65. 65. 66.
Present.
66. 67.
Present.
68.
Present.
69.
Present.
70.
Present.
Okay. Absent roll numbers are roll number 3, 11, 12, 15, 21, 39, 41, 45, 52, 53, 57, 62, 63, 66.
Ma'am, 12 is present.
Ma'am.
Okay, roll number 12.
21, ma'am.
63, ma'am.
14 41.
Wait a minute. Abhishek Molik, what is your roll number? 53 or 63?
63, ma'am. 63.
63. Okay. Any other?
Roll
12,
number 41.
41. Okay.
21.
Okay, 21. Any other?
Hello, ma'am.
Okay. Hello.
Ma'am, roll number 15 is also present, but due to network issue, she is unable to give the presenting.
Roll number
15.
15.
Yes.
Okay. I will check chat box. Okay. If she has
Ma'am, her message is also failing to send.
okay, I will check.
Okay, ma'am.
Yeah.
Thank you.
Okay, thank you. You can leave the lecture.
Ma'am, 15 present.